Brains can behave in very strange ways. Shall we find out why? From freezing in doorways to unexplained visual illusions, the human brain holds many mysteries. Could computational modeling be the key to unlocking them? In the Young Computational Neuroscientist program, students go beyond textbooks. We turn puzzling observations into scientific questions, building computational models to test our theories and discover how the brain really works. Our journey begins with a foundation in neuroscience, math, and Python. From there, you will explore 3 core approaches: feed-forward networks to transform data, attractor networks for memory, and reinforcement learning for decision-making. Using these powerful tools, you'll investigate 6 fascinating mysteries: visual illusions, face recognition, Alzheimer's disease, bipolar disorder, Parkinsonian freezing, and ADHD. Each path offers a unique look into the brain's complexity. You will work in small teams as researchers. Together, you will study evidence, construct models, run simulations, and compare normal versus altered conditions. Ask yourself, does your model explain the phenomenon, and what can it predict? Every team will develop a working model, generate testable predictions, create a research poster, and present their findings at a symposium. No prior coding or neuroscience experience is needed. Just bring your curiosity and basic school math. The Young Computational Neuroscientist program is waiting for you. Choose your brain mystery, join a team, and start your investigation today.